The final's basically the same format of the questions. I just changed numbers and like maybe sines to cosines and things like that. Like I didn't change the process at all. Like, so the first question will be a second derivative of a problem that looks very similar to this. All right, so when we're looking at this one, you could do this one a couple different ways. You could actually just distribute out the square, or you can do the chain rule. It doesn't make much difference which direction you want to do. I'm going to distribute out the square because it's actually faster. If that was a higher number, I would do the chain rule. But squared actually is easier just to multiply it out. So we get x to the fourth plus 2x to the fifth plus x to the sixth. So now we just do the derivatives of them. So we get 4x to the third plus 10x to the fourth plus 6x to the fifth. Remember, derivatives, you bring the exponent down and then subtract 1. Don't get confused by the antiderivatives that we were doing in the past couple weeks.
Oh, okay. So did it what does it look like into the chain rule?
Huh? I can do the chain rule. I can do the chain rule in a minute.
Okay, yeah, because I don't want to see it
That's fine.
as an incorrect answer, but
So
I think about doing the chain.
I can do the chain rule too. All right, so that's the
If we
answer.
took the 2 out, at 2 times the polynomial or whatever it is, that would
That's fine. Yeah. Yeah. If you, so here's typically how I end up doing it. So if your answer doesn't look like mine and I can't figure out what changed the answer, I'll take a number, just a random number. It's not 0 or 1. Normally it's like 5 or 6. And I'll plug it into your answer and my answer. If it comes out to be the same, you're golden. If it doesn't, you're not. So that's literally how I check it. I just pick a number and plug them into both of them. Because if it's the exact same answer, it should come out to be the exact same number. So, yeah, but that I'd usually be able to figure that piece out. So if we did the chain rule, so the chain rule is the derivative of the inside. So the derivative of the inside is 2x plus 3x squared. And then it's times the outside. So then it would be that times 2 parentheses x squared plus x to the third. So you'd get 2x plus 3x squared times x squared plus x to the third.
And don't you distribute that?
You don't have to.
Yes.
If you distribute it, you're going to get right back to that.
Okay. I think that's what I did wrong because I thought like the parentheses with the base.
Oh, sorry. I only did one derivative on it. I only did one derivative on it. Like, I was going to say, it doesn't come out to be right because I only did the first derivative. So the second derivative, you have to basically do it again.
So I learned that.
Did you want to take the test today?
I do.
Here. Just go to the library. If we're not here when you're done, just put it in the mailbox.
Mailbox?
Yep.
You guys have an assigned mailbox?
Yep, in the mailroom you'll see one. It's alphabetical. Just, or if you can't find it, just ask. But yeah, I have a mailbox there.
Take one again there too?
Yeah. So at this point, yeah, we have to do the second derivative of it. You could do the product rule for it, or you could distribute it out and multiply and do it out. So at this point, yeah, just distribute it. So we get.
Yeah, now I see it.
So why this is easier over here. So you get 2x to the third plus 2x to the fourth plus 3x to the fourth plus 3x to the fifth. So we've got 2, 6x squared, what's that, 5? So 20x to the third plus 15x to the fourth, which does give you exactly what that is if you distribute the two. So it's like, I think distributing it at the beginning definitely makes that one easier, but again, it does come out to be the exact same answer. So. And the product rule, you could do the product rule here. It wouldn't actually make that drastic of a difference either, instead of distributing it. Just let me know when you're done writing. Go on to the next one.
Show really quick the regular distribution of it that you did first. How you got what time?
How I got this?
Yeah, when you just do it out, like do it by square.
Okay, hold on. How I got this before I did the derivative?
Yes, sorry.
Okay. I was going to say, wait a second.
Sorry, yeah.
No, you're fine. So x squared plus x to the third times x squared plus x to the third. So x to the fourth, x to the fifth, x to the fifth, x to the sixth. Huh?
Because I can't see the 4x and stuff like that. I don't know if it's a... No, it's a projector probably.
That's weird.
Wait,
Yeah.
is it lower?
No, because it's not the projector. That's
So
weird.
Is it lower in the computer?
No, I can see it. Hold on. I'm like, I can see it.
That's strange.
Yeah, normally. There we go.
Got it.
Okay.
Just a glitch. Yeah, because I just have it mirroring on, so it should be the exact same as what I'm saying.
I messed up on one of the signs and somehow Cathro still ended up making them both negative.
You made them both negative. There's no negatives in this problem.
But I somehow did that and ended up with positive.
It's okay. I probably would never have caught it because I wouldn't. If you had the right answer at the end, I'm not going back and really looking at the rest of the stuff, except to see that there's stuff there.
You know, you would have seen the one sign.
I would have seen one negative sign and go, huh? And like, oh, he probably just forgot to put the extra line there. We're good. All right. Do be careful of what it's asking. They change. Okay? So I've asked first derivatives, I've asked second derivatives. So this one's asking for the first derivative. So just make sure to answer what the question's asking you. Hello. Just started. You only missed the first question, but I'm recording it, so you can always go back and look at it. This one, you could do the quotient rule for it. I would not. I would break this up. So if there's only one thing in your denominator, break it up. It's going to make your life a lot easier. And no, I'm not going to go through and do the quotient rule, just because it's literally a mess. So this one, just break it up. So we have x squared over square root of x minus x over the square root of x. Actually, no, I'm going to change that before. Get rid of the square root of x. So it's x over 1/2 minus x over x to the 1/2 plus 2 over x to the 1/2. So I've got x to the 3/2 minus x to the 1/2 plus 2x to the negative 1/2. So I just literally divided them all by x to the 1/2. And now they're doing exactly the same thing we basically did in the last problem.
Oh, do subtracting. Yeah, division.
Division, subtracting of the exponents, right. So I bring down the 3/2, so that becomes x to the 1/2. I bring down the 1/2, that becomes x to the negative 1/2. And I bring down the negative 1/2 times 2 is negative 1. And then it's x to the negative 3/2. if you want to rewrite this, we can actually move everything down. You're going to divide it by, so we have, actually, just move it over here.
Is that probably plus or minus one?
Yeah, well, it's a plus a negative one, because it's 2 times negative 1/2, which is negative 1. So it's going to be a negative, yeah. So it's going to end up being a negative in a second. So I would end up getting x to the 3/2 down the bottom as my exponent, or as my denominator. So I have 3/2 x squared. If I'm going to get a common denominator. So if you did this in the quotient rule, you're going to end up getting something over something. So, and then we have minus 1/2 x minus 1. And that's what you should end up getting.
How did you find a common denominator?
It's just the biggest exponent. It's just the biggest fraction. Actually, technically, the common denominator should have been 2 to that. But
But if we left it like that, that's fine.
I'm not marking it wrong. Technically. It should have been 3, 1, 2, and then 2. That's what it should have been.
But if you leave it like,
I would have, honestly, if you would have left it like that, I'd been fine.
oh, okay. Oh, sorry.
All 3 of those are the exact same thing. It's just rewritten of it. So if your teacher tells you to get rid of all the negative exponents, the first thing I did there was fine. If they want it as one fraction, then the last one's there. So again, it really just depends on which, like this one, you're only finding the first derivative. You don't need to do anything else with it. So any of those formats is correct. So I would leave it as simplified as, or as the least amount of work as possible so you don't mess up.
Why don't you leave the x to the 1/2 just like not in the denominator for the 3 seconds?
Because, so the biggest one is x to the 3 seconds.
Right.
So this x to the 1/2, I multiplied by x. So I had to multiply the top by x.
I'm just talking, not the one.
Oh,
I'm just talking about when you arrowed over to it in the first 3 seconds.
oh, it's just, I just didn't. Because I wasn't putting anything in the denominator, so.
Okay, but if we left it in the denominator.
Yeah, it'd be fine. Yeah.
I don't know if that was some special rule.
No.
So I don't remember that.
Nope.
Oh,
Yeah, because the other two, I actually put an x down in the denominator, so putting the number there makes sense.
Yeah.
This one, I wasn't moving anything down, so.
Right.
Nope.
Wait, I overthink.
Wait a minute.
Okay, good.
All right. Okay, go back. No problem. All right. So this is the second derivative of x squared sine pi x. So in this case, we have to do the product rule, and we kind of have to do the chain rule because of the pi x inside there. All right, so product rule, if we make the f of x x squared, f prime of x is 2x, g of x is sine pi x, so g prime of x is pi cosine pi x. Because it's the derivative of that, which is pi,
Yeah, pi's a number.
times cosine of pi x. So my first derivative is 2x sine pi x plus x squared pi cosine pi
You can
x.
flip it the other way, right?
Yeah, I'm actually going to.
You could also say cosine pi x squared.
I would not do it that way. Just because if you're going to do it that way, you kind of have to put that in parentheses. Which, if you did that, that's fine, because otherwise it kind of looks like everything's inside the cosine.
Yeah.
So,
But as long as I did that.
yeah, as long as you put parentheses around it, so it doesn't that's fine. Yeah.
Gotcha.
It's same thing like with square roots and stuff like that. You typically put the square root at the end because things after it kind of like look like they're in it when they might not be.
Gotcha.
So, yeah.
Wait. Isn't it, correct me if I'm wrong, but isn't close product rule supposed to be f of x times g prime of x, and then vice versa, so the answer here I got is 2x squared times pi cosine of pi x plus 2x sine times sine of pi x, or no?
So you basically have the same thing, just reversed, except you have an extra 2. And I'm not quite sure where the extra 2 came from. You have 2 pi x squared, and I don't know why.
Oh no, it's 2x times sine.
Right.
Yeah.
That's what we have.
Yeah.
And then pi x squared cosine pi x. You could write it the other direction. That's fine.
Oh no, I just did x squared times pi cosine of pi.
That's fine.
So I don't know. There is no 2.
Okay, you're fine. You have the exact same answer. You just wrote it in a reversed order.
Oh, okay.
So you can group the x squared with pi instead of just,
Yeah. Pi is just a number, so it's like
well, I know, but instead of putting x squared first.
it doesn't make a difference. It'd be like saying if you forget it's pi, if you put a 3 there, would it matter if I put the 3 in front or the 3 after the x squared? No. So pi doesn't matter either. So typically you put your coefficients first. And pi in this case is a coefficient, so it'd be going first. It doesn't make a difference in the way you're going to do the calculations. Remember, multiplication, you can put in any order you want, it's still going to give you the same thing. Addition, you can put in any order you want, it's still going to give you the exact same thing. So when she did it the opposite direction, it's fine. If you remember, when you're looking at the quotient rule, it is very specific. You have to do f prime of x times g of x minus. So I said when you're doing the product rule, if you do the same thing, you get in a habit of always doing f prime of x first. You won't screw up the quotient rule. So that's the only reason I do it that way. It doesn't make a difference because it's addition. All right. So we want the second derivative, so we have to do the derivative of this again. So in this case, since it's addition, we're basically looking at each one individually. So actually, I'm going to do this on another slide because it's going to get a little bigger. All right, so if we look at that part first, so f of x is 2x, so f prime of x is just 2, g of x is sine pi x, so g prime of x is pi sine pi x, or not sine cosine pi x. So we have 2 sine pi x plus 2x. Actually, I'm going to put the pi in front of the x. 2 pi x cosine pi x. And then if we look at this one, f of x is pi x squared. So f prime of x is 2 pi x. G of x is totally running out of room. G of x is cosine pi x. So g prime of x is negative pi sine pi x. Because it's negative sine of. So I've got 2 pi x times cosine pi x plus pi x squared times pi sine pi x. I'm not going to. I'm going to clean it up though. So I have 2 sine pi x. These two right here are the exact same thing. So I can put them together. So it's 4 pi x cosine pi x. Then I can do the pi squared over here. Pi squared x squared sine pi x. And that's my final answer. Oh, I forgot the minus sign. In that one. So that is a minus sign. Could what?
Nothing. I was gonna rewrite the top line, but rewrite the top. That's fine.
Okay. So the only thing you're doing when you're rewriting it is the middle two terms basically end up being the exact same.
The
So you're
pi
adding.
for the sine is negative.
Yeah. It's negative pi sine x pi x. Because when you do the derivative of cosine, it's negative sine.
Yeah, I understand that for sine. But
Yeah.
so that also affects pi.
Well, it's -1, so it's pi times negative sine pi x.
Yes.
So I'm just moving it's just like the 3. I'm just moving the negative sign in front of the pi. Because you don't typically put a negative sign after.
Yes, it's just, I always, for some reason. Okay, I understand.
Yeah, it's.
Yeah, when you call back that, yeah. When it's just it's like one.
That's just the little things.
I'm trying to figure out like how we can just drop down the 2 sine pi x. That's adding, not multiplying. But never mind. I think
Okay. All right. Any other questions with this one? You only missed the first 3. Well, I'm recording, so it'll be up online too. So. All right. Next one. Again, this is the first derivative. So we've got ln's. We've got to do the chain rule. Actually, on both of them. Remember on this one, that right there is the same thing as that. So you have to do the chain rule for that one. Okay. So So we'll do this one. I'm going to do this in a couple different colors. So let's do this part first. So ln sine of x. We do the derivative of sine of x is cosine of x. The derivative of ln is 1 over x.
So that would be 1 over sine x?
Right. So that would be 1 over sine x. So that's cosine x over sine x, which is cotangent x. Now if we look at this one, the derivative of sine x is cosine x, and then we bring down the 2, so it ends up giving you negative sine x. Because 2 times negative 1/2 is negative 1.
Okay, yep.
It's not 2 cosine? Wait.
The derivative of the inside, so the derivative of sine of x is cosine of x.
Yeah, no, it's sine squared because of chain rule, right? It's just kind of how it will plus multiple times the derivative of the base.
Right.
What will happen is, oh, it's just 1. How did I get a 2?
Because you end up having, because you bring down the 2, but you have to multiply it by negative 1/2. Because there's a negative 1/2 in front, which is where the negative 1 comes from.
Oh, wait, no, that's in my calculation. I don't know.
So this is just negative cosine x
Okay.
sine x, which you can't really do anything with.
Yeah, okay.
So y prime is cotangent x minus cosine x sine x. I would do it like that in pieces. I wouldn't try to go directly to the answer because odds are you're going to mess something up with the steps. So doing it in pieces eliminates a lot of that little part mistakes that you can make.
Oh, no, just got the
I
money.
just
I was
wanted to
looking
do
at
the
it.
chain rule out,
Huh?
the chain rule.
I did do the chain rule out.
Right.
Which part?
I just do mine in a very, like I read like use this, so prime is this.
Oh, that's fine.
I can't like do it, like I can't just have, yeah, here, yeah,
That's fine.
you're a special breed, so it's okay.
You're fine. As long as you understand what I'm doing and like you can translate it to it the way you want to do it, that's fine. If there's something that I wrote down that you don't understand, let me know and I will try to explain it to you again. So, yeah, it's like if you want to break it up like I do with the f of x and the g of x, that's fine.
That, yeah, that I can do.
Yeah, that's fine.
Oh.
So, all right. The next two questions are finding. Actually, yeah, the next two questions are finding tangent lines. So we have to find the derivative, get that as a slope, and then plug back in to find my tangent line. Okay. So first thing we have to do is find the derivative. So now this one, you have to do the quotient rule for it. So we have f of x is x squared minus 1. So f prime of x is 2x. G of x is x squared plus 1. So g prime of x is also 2x. So y prime, so it's the derivative of the first, so that's 2x times the second minus derivative of this bottom times the top. all over the bottom squared. So remember f prime g minus f g prime, or actually I think I did it g prime f. G prime f over g squared. That's the quotient rule. All right. You don't have to simplify this.
Oh,
I now, because, so there's the things, like, if you needed to simplify it down to just give you the y prime or to find the second derivative and stuff like that, do it. We're looking for a slope at this point. I know my point is 0, 1, or 0, negative 1. So I can plug 0 into this problem right now and get my slope. So y prime at 0, so I have 0 times, well, whatever, 1 is still 0. 0 times that is 0, and that's 1. So basically, my slope is 0.
and the way to write it is in
Slope-intercept form.
oh,
Slope-intercept or point slope, it doesn't make a difference.
okay, point slope. So I got y plus 1 equals 0, parentheses x minus 0. And then y is equal to 1.
Yes. Well, y is equal to negative 1.
Oh, wait. Oh, yeah, negative 1, correct. Actually, wait.
No. Oh, no, yeah, because it's times. Okay, no, yes.
Right, because that's 0
Yes, 0
times 1, 0 times 1 over 1.
No, yes, I just
So it's
I
0.
I just forgot.
Yeah,
The multiplication because all
that's fine.
and
So my slope, so if I do the y equals mx plus b, I have m is 0, then I have my x and my y. So I have negative 1 equals b. So my equation that I'm looking for in this case is just y equals negative 1. It's a horizontal line. And remember, you can always check this by graphing. So if you did x squared minus 1 over x squared plus 1, you can see at that point right there, it's a horizontal line. It's a minimum point at that point, so it'd be a horizontal line. So you can use Desmos to check your answers for these. The first 4 you can't, but this one at least you can. All right, any questions on this one? All right, next one. Same thing, we're looking for the equation of a tangent line. So I've got my equation, I have to find my derivative of this. So we're going to rewrite this problem so it's a little bit easier to see what you need to do. So this one we have to do the chain rule. So there's that. And then I have u to the 1/2 is 1/2 times u prime. Is that how you're writing it?
Yeah.
There you go.
It's dumb, but it works.
No, it's fine. It's like, as long as whatever steps you need, like the last one, there was just, I had to do it too many times. It was going to be a problem.
No,
Like this one, it totally made it was easy to do it out. So, but no, whatever, like that's how I showed it to you originally. So it's fine.
Yeah.
So I've got 1/2 times 1 plus 4 sine of x times 4 cosine of x. So again, I don't have to simplify this problem down. I can just plug in 1 and see what I get. So I have 1/2. Sine of 0 is 0, so that's just 1. Cosine of 0 is 1, so that's 4. So 1/2 times 1 times 4 is 2. So my slope is 2. All right, so now I've got to plug in, so I've got my y equals, you could do this, this one actually is probably easier to do with the point slope formula just because we have an m. The other one was easier, it was just the y-intercept stuff. So I have y minus 1 equals 2 times x minus 0. So I've got y equals 2x plus 1. That's my tangent line. Any questions with that one? So those are the two tangent line problems. Okay. 7 and 8. 7's local and absolute extreme values, so mins and maxes. And 8 is concavity, the inflection points. So this one, we have to find the first derivative and then find out where it equals 0. Notice you have a domain restriction, it's negative pi to pi. So we're not looking at it forever. And that's one complete curve of cosine of x. So it actually, I probably should have used 0 to 2 pi for this one. I just realized that I screwed that up. That's fine. Doesn't make a difference. All right. So f prime of x. Actually, I'm going to change this to y. Oh, actually, it doesn't matter this one. Derivative of x is 1 plus 2 negative sine of x. So I get 1 minus 2 sine of x. Why I did that. All right, so now we need to figure out where this equals 0. So sine of x is, well, actually in this case, you're looking where it equals 1. So we've got 1 minus 2 sine of x equals 0. So I've got 2 sine of x equals negative 1. So sine of x equals 1/2. So we're looking at where sine of x equals 1/2, which is at pi over 6 on the unit circle. Yeah, because 1/2 square root of 2 over 1, 2, square root of 3 over 2, and then 1. So that means x is pi over 6. It would also be negative pi over 6. And it would also be negative, or 5 pi over 6. So 5 pi over 6 and negative 5 pi over 6 are the 4 values. So those are where the extreme values are. Now we just need to find those values at that point. Yep. So if we look at the unit circle, that point right there is square root of 3 over 2 1/2, which is pi over 6. If you'd like to put a nice little unit circle on your note sheet, that might not be a bad idea. And you only really need the first quadrant, because if you can figure out the first quadrant, you can use that to find all the other quadrants. So because it's the first quadrant and the bottom you go down is the same thing, it's going to be the negative version of it. And then if you're going over to the second square, or the second quadrant, it's the closest one to the actual axis. That's why it's 5 pi over 6, because it would give you 6.
0, half pi, pi, 3/4 pi, and then 4.
That's the y one?
Yeah.
Hold on.
Right?
Those are the x values.
Okay, so you have sine of x equals 1/2. How
Yes.
do you get 3 over 2? Did you just plug it in?
No. That's the point on the unit circle.
And it, yeah, I wasn't about my
It's fine. That right there, I'm just going to move it over here. So that point right there is square root of 3 over 2 1/2. That's the y. That's the sign. Sign's the y value.
But why? No, I meant it's just like I get why I don't know why you need 1/2. And then why and then
I need to figure out where this is 0.
that's where there, so
So 1 minus 2 squared sine x equals 0. So that means sine of x equals 1/2.
oh, and then you plug it back in.
So I'm looking for the values that are going to give me 1/2 when I plug in for x, which is pi over 6, negative pi over 6, 5 pi over 6, and negative 5 pi over 6.
Yeah, I still
Which part do you not get how I got that?
no, I get why you got the 1/2. It's just I don't get why you got the 3 over 2.
Oh, okay.
This?
Yes.
That's the unit circle. That's just where that point is. That's the cosine value. I didn't do that from the problem. That's just the unit circle.
Oh, that just helps you?
Yeah.
Why do you get pi over 6? Why do you get x to pi over 6?
I will show you.
Yeah, I put up in decimals.
I need one with.
Okay, yeah, okay. Now, okay, that makes sense. It's just I don't know what
Yeah, that makes
relevance
sense,
does
yeah.
it have towards the answer.
All right, so here's my unit circle.
Okay.
Which values give me sine of 1/2? Pi over 6, 5 pi over 6, and then since I'm doing the negative side of it, negative pi over 6 and negative 5 pi over 6.
Okay.
Okay, so those are the 4 values that give me sine of sine of that value gives me 1/2. So those are my x values of my. At some point, like those are the mins and maxes. I don't know which ones are which yet, but those are my mins and maxes. Okay.
The min is square root 3 over 2?
No, this is nothing.
Okay. Good.
This right there is right here.
That just give you less.
That's right there. See, pi over 6 is square root of 3 over 2 or 1/2.
Okay, so
That's
this
just
goes-
telling me where that
no.
point was. Yes. It's not giving me a value for that.
And
It's
then
just,
you just plug in 1/2 into f of x. Correct.
no, I'm plugging the x's. The pi over 6, the negative pi over 6, those.
Oh, that's what gives you 1/2.
Yes. So these are the x values that are going to give me my mins and maxes. So now I have to plug those into the problem to find out which ones are my mins and maxes. Alternatively, so basically we need to know what's happening before it, what's happening after, right? So you don't necessarily have to plug it back in. You just need to know if that's giving you, if it's increasing to it, decreasing after it, we're good. So I've got, here's my, so I got negative pi, negative 5 pi over 6, negative pi over 6, pi over 6, 5 pi over 6, and pi. So what did I have? 1 plus or 1 minus 2 sine x. All right, so between negative pi and negative 5 pi over 6, is this positive or negative? Is the question. So if I look, that's over here, right? Because that's negative 5 pi over 6. So between here and here, the value is negative. It's going from 0 to negative 1/2, right? So that means that it's negative there. If we look at from here over to here, it's still negative. If we're going from here to here, it's going positive. So that right there is the minimum, because it's decreasing to it and increasing after it. If we're going from here to here, it's staying positive. And here to here, it's also positive. So I have a minimum. That's it.
Do you need to look at the unit circle when you do the final?
No. Well, wait. Yes, you're going to need to use basically this. The only difference between this problem and the problem on the final is I changed the number. So yes, you could do it other ways. So like you could take this problem and graph it and see where it comes out and figure out mins and maxes that way if you want. After you, the key piece that I need to see is I need to see those points. And then how you tell me which are the mins and maxes is on you. There's multiple ways to do that. You could graph it. You could look at this way, plug them in.
You just want us to say, like, hey, we used Desmos and it told us that it's positive or wrong.
Yeah, that's fine. Yeah, or honestly, if you're going to use Desmos, just do a quick little sketch of the graph.
Okay.
I forget. So you said Desmos, which one do you plug in, the derivative or the original?
Well, either way, if you plug in the derivative, you're looking for where before and after is positive or negative. If you plug the original, you're actually looking at where it's mins and maxes, because those are the values you're looking at. So it just depends on which one you want to use. If you do the derivative, it's going to be very similar to what I just did there, looking at those values there. Yeah, just tell me it's the absolute min, absolute max. Honestly, I'm less worried with the absolute local as if it's min and max. Okay. Okay. All right, 8. These are the inflection points. So we're looking at the second derivative. I do not need to know the concavity intervals. I'm just looking for the inflection points. So all I need to know is where they are, so the x values. So we're going to do the second derivative of this and then set it equal to 0. All right, so I've got and since I took this from the book, I have a sneaking suspicion that it's going to be messier than it looks. All right, so we've got 18 x to the 5th minus 25 x to the 4th plus 4x to the 3rd minus 5 or 15 x squared minus 4x, and then that's gone. Second derivative. 90x to the 4th minus 100x to the 3rd plus 12x squared minus 30x minus 4. Yep, just as messy as I expected. It's fine. Graph it on Desmos, because it's not going to be easy to factor. All right. So I want to zoom up, make sure it doesn't actually cross anything crazy later on. So it only crosses twice. At those two values. So those are my two inflection points. Yes. I literally just changed the number.
Yeah, it's going to be different long. You could do Desmos.
Yeah. Yeah. If you can't factor it, just use Desmos. Yeah, you probably could factor this one out, but it's going to be a mess. It would not factor easily. So, yes.
So the inflection point is, it seems to be when it's the y-intercept. I don't know.
So, okay. So, inflection points and absolute mins and maxes are the exact same thing, just on different derivatives. So, on the first derivative, where it hits where that value equals 0 is where it changes direction. So that's where it's going to give you a minimum or a maximum. The second derivative, where it equals 0, gives you the inflection points. That's where it's basically the derivative is changing from positive to negative, so that the actual slope is stopping getting bigger and starting to get smaller again. So if we were to look at the original problem, if you look at the original problem, you can start to see right there, it starts to change, it changes direction. And then on it dips down way down below. But you can see it, like even on this one, it changes direction at some point over in there. So that's where the inflection points come from. All right. 9 is an application problem. So a hockey team plays in an arena that seats 15,000 spectators with the ticket price set at $12. Average attendance at the game has been 11,000. A market survey indicates that for every dollar the ticket price is lowered, the average attendance will increase by 1,000. How should the owners of the team set ticket prices to maximize the revenue from ticket prices or ticket sales? So basically we have to set up our equation, and we're looking for, in this case, a maximum. All right. So my ticket price is set at $12. So it'd be 12 minus X. So I'm going to lower it by $1 each, right? And then my attendance is 11,000 plus 1,000 X. So my revenue,
X be?
how much I'm raising my ticket price by. So or lowering my ticket price by. For every dollar I lower my ticket price by, I gain 1,000 people.
Oh, X number of tickets. No, not number of tickets.
No, X is how much I'm lowering my ticket price by. It's not the number of tickets, it's how much I'm lowering it by. So revenue is 12 minus X times 11,000 plus 1,000 X. And again, all I did was change numbers. So this application problem, it's not going to be a volume problem. All right, it's going to be a ticket problem. All right, so does everybody understand how I got the equation? Well, you understand how I got the equation? Okay. Because now the next thing I have to do is the derivative of it. So it's up to you if you want to multiply it out, or if you want to just do the product rule. Doesn't make much difference. Honestly, I think the product rule is actually faster for this one, just because it's going to get rid of most of your x's anyway, and it saves you that extra step. So I'm just going to do the product rule. So f of x is 12x minus x. So f prime of x is negative 1. G of x is 11,000 minus 1,000x, or plus 1,000x. So g prime of x is 1,000. So r prime is negative 1 times 11,000 plus 1,000x plus 1,000 times 12 minus x. So cleaning it up a little bit, I get 1,000 minus 2,000x. So if I set that equal to 0, I get 1,000 equals 2,000x. So 1/2 equals x. So how much is my ticket price going to be? I just plug it back into my ticket price. So 12 minus a half is what? No. That's 12 times a half. 12 minus a half. 1150. So that'd be the answer. $11.50. And I'd have 11,500 people there. That'd give me the most money.
So, what should be the strategy when tackling a problem? Like that, I mean, I'm okay with optimization of volume. I'm just not that good when it comes to like tickets and revenue. So, what are any strategies to tackle this problem?
Exactly like I just did it. So figure out. So revenue is just price times attendance. So like price by how many times you sold it. That's what revenue is.
Okay.
So the ticket prices, it started off at $12, and for every dollar it went down, so it's basically minusing 1x. That's why I didn't put the 1 there. And then your attendance changes too. So your attendance starts off at 11,000, and it was going up by 1,000 for every time you changed it by a dollar. So it's 1,000x. And then it's just multiply those two. So the other thing you got to remember is no matter what you do, you're going to get a quadratic. All right? There's going to be an x in both pieces. If you don't have an x in both pieces, you screwed up. If your derivative comes out to be a single number, you're screwed up. Because otherwise, then it's not optimized. There's no way to optimize it. It's a linear equation.
Oh, can you repeat the last statement?
It's got to be a quadratic.
Okay.
It's got to be a parabola when you graph it. So notice I have an x in both my multiplication. So I'm going to have an x squared. And when I did my derivative, I have a linear equation. That's fine. If you get a whole number here because you lost all your x's, you screwed something up.
Okay. Good to know.
All right, one more to go. L'Hopital's rule. All right, so we're looking at the limit as it goes to 0. What's the very first thing I've always told you to do?
Plug it in.
Plug the number in, make sure it actually is something you have to do. All right, in this case, if I plug in 0, I get e squared minus e to the negative 2. Oh no, sorry. E to the 0, which is 1, minus e to the 0, which is 1. So 1 minus 1 is 0. ln of 1 is 0. So I have 0 over 0. Right? Okay. So I have to do the L'Hopital's rule. So that means do the derivative of the top and the bottom. So f of x is ex squared minus e to the negative 2x. So f prime of x is 2 e to the 2x plus 2 e to the 2x. Derivative of 2x? No.
Okay, making sure.
So, hold on. L'Hopital's rule, first of all, it has to be a fraction, which is a fraction. And you're doing the derivative of the top and the derivative of the bottom. You're not doing the quotient rule. You're doing literally the derivative of the top and the derivative of the bottom.
It's just when I see f of x and f prime of x, I don't know why my mind just automatically sets to g of x and then the whole quotient rule.
Well, that's it because you have a fraction, so that would make sense. That literally would make sense.
I didn't do. I think it's just late at night. So
No, the quotient rule totally would, like when you look at I of a fraction, that It's this in front that tells you it's not the quotient rule, because I'm not looking for the derivative of this function, I'm looking for the limit of it. So my g of x is ln of x plus 1. So this one we have to do the chain rule on. So the derivative of x plus 1 is 1. And then I have 1 over x plus 1, which is just 1 over x plus 1. So now I'm looking for the limit as x goes to 0 of 2e to the 2x plus 2e to the negative 2x, because I screwed that up and didn't put the negative sign back there. And Scott didn't catch me.
Okay.
Yet. He would have in a minute. So now if we plug in 0 to this, I have 2 plus 2 over 1 over 1, which equals 4.
Oh. Okay, I did something really wrong.
So my limit is 4.
And then I did the answer. Okay.
Oh, you plugged in 0?
Yeah.
Oh.
Yep.
Oh, okay, yeah, I did two change flips.
You could have. It's just not helping you much in this problem.
And then I just did the answer, which is 0. Okay. Oh, okay. So keep it as it is.
Even if you did keep change flip, you're still going to get 4.
Okay, yeah, so I did it wrong.
Because you did 2 plus 2 is 4 times 1. If you did keep change flip, you would have gotten this. That's what you would have gotten, which still would have given you 4. So, and if it doesn't work, do the derivative again. Okay, that's the thing with the L'Hopital's rule. You can literally keep doing the derivative until it gives you something that works.
What page should I? Oh wait, no, I'm.
It goes pretty much in order. Chapter 3 and Chapter 4 is basically what's on the test. A couple of things from Chapter 2, because the end of Chapter 2. Nothing from Chapter 5. I rolled all the algebra into the problem, so I didn't have to do Chapter 1. So, which is basically the end of Chapter 2 through Chapter 4.